Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 12, more on tangent segments. Okay, so here we go. Classwork opening exercise. In the diagram, what do you think the length of Z could be? And how do you know? Well, this is a point, and this line going up to here is labeled as being a length of 8. And it touches this circle right on the edge, so that would be a tangent. And then this line goes over to the other side of the circle, and it is touching the other side of the circle, so it is a tangent of this same circle, so it has to be 8. So this is 8. And then since this is a tangent to this big circle here, and the other side's also a tangent to that big circle there, then that is also 8. So you get the idea. This is a tangent of this circle and this one. So since both tangents have to be congruent, all of these are going to end up being 8. So therefore, Z is going to equal 8 because each successive segment is tangent to the same circle. So the segments are congruent. Okay, in this one it says, in each diagram, try to draw a circle with center D that is tangent to both rays of angle BAC. So what they're saying is they want a center of a circle here so that it is just touching this line segment and this line segment. So if I got my compass out and brought it down here and turned the ink to, let's turn it red, and I put the compass right here. Let me see if I can get that centered better. What just happened? Let me see. Right about there. And open this up so that it's got a radius of C. Trying to get it centered better. That looks good right there. And then open that up for a radius of C. And then I draw it. There's my circle, centered at D with a radius of C. So this line is going through the circle. That is not a tangent. That's what we call a secant. And this segment AB missed entirely. So it's just a line segment that's exterior to the circle. All right, so if I do the same thing over here, and I'll just try to save some time here, maybe make that a little bit smaller, centered at D, then can we do this one? I think we can, but actually let me use the compass. So if I put the compass here, and why does it keep doing that? I'm trying to move the compass right, left. There we go. Okay, that's about as close to center as I can get right there. Rotate it up so that lines up with C. Open it. Okay. Center D that's tangent to both rays BAC. So if I draw this around like this, obviously going through the point C is not going to be tangent. So that's too big. So I'm going to try to make this smaller. So then I shorten this up to here, so that that's coming around, and there you have it. There is a circle. It's off just a smidgen, but if I just move that up just a little, and if I made the radius a little bit bigger, then you see that it would touch here and here. It doesn't have to touch at those points. So now if I go back to this one and do the same thing, let's see what will happen. If I shorten this up so that the radius is from D to that segment, so I'm just touching right there, see that? And if I come around, obviously that circle's way too small to touch AB. All right, so here is a circle tangent to, or AC's tangent to the circle, and AB is also tangent to the circle on this side. All right, page 2 gives us another diagram. And it's obvious, I hope that now that you see that if I drew a circle centered at D, it's going to be a teeny weeny little circle, and it's going to be nowhere near AC, just by glancing at it. But anyway, here you go. There's your circle. Is it tangent to AC? No. So in which diagram did it seem impossible to draw such a circle? Well, it was the first one here, A, this one here, and the other one was this one, C. Why did it seem impossible? Because the point that the circle was centered at is on a line that bisects the angle, as you can see there. So whenever you have that situation, if you draw a line from the point outside the circle, the external point, the exterior point, to the center of the circle, it will bisect the angle that goes out that creates those two tangents. Okay. Okay, now it says, what do you conjecture about circles tangent to both rays of an angle? And why do you think that? Well, I think I just kind of said it, but here it is. If a circle is tangent to both rays of an angle, then the center lies on the angle bisector. We saw this in all examples. Well, there's only one example. This was not center. It wasn't a bisector, but this one was. Okay? All right, so carry on. Exercise 1. You conjectured that if a circle is tangent to both rays of a circle, then the center lies on the angle bisector. So rewrite this conjecture in terms of the notation suggested by the diagram. So what are your givens and what do you need to show? Okay, so what are we given? Well, we have a circle with center P, check. And tangent to segment AB. It's tangent to this, and it's tangent to AC. X equals the measure of angle CAP, and Y equals the measure of angle BAP. We need to show that X equals Y. Okay? Okay, page 3, part B says to prove your conjecture using a 2-column proof. Okay, so remember what we're trying to prove. X equals Y. That's what we're trying to prove. So the first thing we're going to say is the measure of angle CAP equals X degrees, and the measure of angle BAP equals Y degrees. Okay, and those are both going to be given. Okay, all right. Then we're going to say that if we have a line segment, I'll do it in red. These two line segments, therefore. So then I would say segment CP or PC, segment CP, segment PC, CP, doesn't matter, is perpendicular to AC. And PB is perpendicular to AB. Okay? And the reason is tangents are perpendicular to radii at points of tangency. Okay, and then we're going to say that triangle A, B, P, and triangle A, C, P are right triangles. And that's just simply the definition of a right triangle. Okay, so now we have two right triangles. So where's our right angles? It's at the points of tangency here and here. Okay, so now we can say AP equals itself, reflexive property. Okay, so I'll label that. Okay, this side right here, AP, is perpendicular to itself. And then we can say PB equals PC. And the reason for that is, well, PB and PC, all radii of a circle, are congruent. Okay. All right, so what do we know now? Well, that we just said that these, let's use, yeah, that's fine, black. We just said that this side's congruent to itself, which is the hypotenuse of triangle ABP, and it's the hypotenuse of triangle ACP. So we just said that the radius, which is the one of the legs, the shorter leg of the right triangle, are congruent. So now we have a hypotenuse and a leg in a right triangle. So now I can say triangle ABP is congruent to triangle ACP. And the reason is hypotenuse, leg. Now I've run out of room here, so let me fix my screen. Okay, so we're almost done. Just keep in mind, keep focused on what we're trying to find. We're trying to find that angle X is equal to angle Y. And now we can name them by our angle measures in these congruent triangles. So now I would say the measure of angle BAP is equal to the measure of angle CAP. And the reason is corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are congruent. So now if the measure of angle BAP is equal to the measure of angle CAP, then we can now say that X equals Y by substitution. Okay, CAP is X and BAP is Y. So if they're equal, then X has to equal Y. Okay. All right, and so since those two angles are congruent, then I can now say ray AP or segment AP, depending on how you want to do it. There is no arrow there, so let's just call it a segment. Segment AP bisects angle CAB. And that's just definition of angle bisector. Okay. All right, number 2, an angle is shown below. Okay, there's angle A. Draw at least 3 different circles that are tangent to both rays of the given angle. Okay, so if I want to draw an angle bisector, that'd be the first thing I would do. Okay, so I'll get my compass. Do you remember constructions from module 1? Okay, so I'm going to put my compass. Let's see, click on the compass and then move it to the center, open it up a distance and draw an arc. Like so. Move the compass over to one intersection point, which is right here. Draw an arc. What is it not drawing? That was weird. And then bring it over to here. I don't know why it does that, but anyway. There we go. Got to have that little arrow on there. All right, so there, I'm on the vertex of the intersection, and there we have, so this is, and then if I get a ruler, I'm just doing this, showing you this one more time since it's been a while since module 1. And then I'm going to put my ruler at A and find that intersection point. And then I'm going to draw a segment from A through that point right there. So that line right there is an angled bisector. And if I choose to put my compass anywhere on there, and that will be the center of my circle. So let's just choose a few. So let me make this black, and I'll put a dot right here. That's the first circle we'll do. If I put my compass there now, okay, right there, and rotate it so that it's horizontal, and then close it so that it's right on that line segment right here. Let's use blue, and I draw a circle, okay? Then it would be tangent. Now, obviously I'm off just a little bit because of the program, but if I just click that and move it to the right 2 or 3 and down there. So then if I move this 1, 2, 3 down 1, then there is a circle tangent to both of those segments that form that angle. It says draw at least 3 different circles that are tangent to both rays of the given triangle or given angle. Okay, so there's one. And I'm going to do it again. How about we center it here this time? All right, this one I'll make purple. So I put my compass right there. And center it a little better. Open this up so it's right on the line as close as I can. And draw a circle. Okay, so there's another circle that is tangent to both. And I can just keep doing this, and there's infinitely many circles. So the next one I will center right here. Okay, so then I'll put my ruler or my compass back here. Open this up to the edge. Right about there. Let's make this one red and draw a circle. So there's another circle that's tangent. The lines are tangent to both sides of the circle. So there's 3 circles right there that are tangent. What was the key to doing this? Drawing an angle bisector and putting the center of the circle on that bisector. So now it says label one of your circles with the center of one of your circles with P. So I'll put P in this small circle. How does the distance between P and the rays of the angle compared to the radius of the circle? And how do you know? How does the distance between P and the rays? So what they're saying is, if I drew a line segment now from P down to the rays of my circle, like so. This one's off a little bit. Like that. How does the distance between P and the rays of the angle compare to the radius of the circle? Well, they're equal. Okay. So the distance between P and the rays of the angle is the same length as the radius of the circle because it is perpendicular to tangent segments as proved in the last lesson. So those are both radii, they're both perpendicular to those segments. So they are equal to the radius of the circle. Okay, page 4, number 3, it says to construct as many circles as you can that are tangent to both the given angles at the same time. You can extend the rays as needed. These 2 angles share a side. So they've already just kind of shown us that. So let me just draw it in there so it's darker. So they're just basically saying that it is, let's see, if we connect these, then it would be like so. Okay, And then it connect and then extend these if needed. So here's what I'm going to just show you real quickly. If I draw a circle just anywhere, okay, and then I can move that around. Obviously it is tangent over here to these two rays, but it's not touching C. So this one over here, it is tangent to these two, but it is not touching A, whatever this one is up here, okay? So how would I be able to find the center of a circle that would be tangent to both? Well, it was just like the last example. So if I get a compass out, and I'll try to do this quickly, then I'm going to construct an angle bisector. So in doing so, I will just move my compass over like so, open it up a certain distance, draw an arc, move this over here, and try to get it as close as possible to my point of intersection, and draw an arc inside that arc, move it over to here, and draw an arc here. So there is my, without wasting time, I won't use my compass, I'll just use my straight line tool. And that center of a circle to be tangent to both of these on angle A, the center of the circle would have to be on this red line. So now I need to traject this up somewhere like so until I'm tangent to this, this, and this. So I'm going to need to extend the sides of the ray coming off of C now. Like so. So I put that there, thin is fine. Start here and go up. And as you can see, they do not intersect. So I need to extend A now. And that would go up somewhere around like that. Okay, so now I'm going to draw an angle bisector for the angle at C. Keep forgetting to switch back to arrow to click on this so I can move my compass. There we go. Okay, there's center. Rotate it around so we're in the interior of the angle and draw an arc. Then move this to this point and draw an arc on the interior. Move up to this point here. And draw an arc. Okay, so then I take my ruler. I'll put 0 at the intersection here. Rotate so I'm going through C. Off a little bit. I'm trying to be accurate here. Okay, and then draw a segment. I'll do it thin. That's fine. Going through there. So where those two centers meet, or I'm sorry, two angle bisectors meet right here, that is the only point where I can draw a circle centered there. So now if I take my compass and put it at P, like so, rotate this around so that we are on this red line, but only stopping at there. And then if I draw a circle, it should be it's too large. Oh, I know why. I can't go out to, I have to be perpendicular. I went out too far. So if I centered it here, then this circle, let's make it a little larger. Delete this circle. And here is a circle, and it's pretty close. It's off a little bit, but you get the idea. There's only one center that'll make that circle fit. so that it's tangent to both angles. And we would just draw an angle bisector. So it says to explain how many circles you can draw to meet the above conditions and how you know. So here would be your all right, so here's what you'd say. There's only one circle. The center of the circle has to be on the angle bisector of each angle. The angle bisectors only intersect at one point. There's only one circle with that point as a center that is tangent to the rays. It is the one with the radius you get by dropping the perpendicular from the intersection of the angle bisector to the side AC. And that's how I set up my, I didn't show it, but that's how I set up my compass. Okay, I used that distance there. I put the compass here, rotated it so that it was there, as you can see. Okay, all right, number 4, in a triangle, let P be the location where two angles bisectors meet. Must P be on the third angle bisector as well? Explain your reasoning. Well, here's the picture. And so where's the angle bisector going to be here? It's going to go through P as well. And we did this in prior lessons. So here's what we would say. And coming at you. Here we go. Lots of words. Shrink it a little. There we go. The angle bisectors of any two consecutive angles are the same distance from both rays of both angles. Let the vertices of the triangle be A, B, and C, where the measure of angle A equals 2x, angle B is 2y, and C is 2z. If point P is on the angle bisector of angle A and B, then it is the same distance from segment AB and AC, and it is the same distance from BA and BC. Thus, it is the same distance from CA and CB, therefore it is on the angle bisector of angle C. All right, so here's what they're saying here. This is B. Here's A, here's C. Let's get this out of the way. So what they're saying is let the vertex of the triangles be A, B, and C. There they are, where the measure of angle A is 2x. In other words, each half would be x. The measure of angle B is 2y. Well, I don't have an angle bisector there yet, so let me put one. Okay, I'm not going to take the time to construct it, but it's going to go from here to P. That will make the measure of angle B 2y, so each half is equal to y. And then C would be z, and z totaling 2z. If point P is on the angle bisector of angle A and angle B, right here, okay, it's on the bisector, the red one, and it's on the bisector, the purple one, then it is the same distance from side AB as it is from AC. And it is the same distance from BA and BC. Thus, it is the same distance from side CA and CB. That's all they're saying. Okay, hopefully that picture diagram helped. Okay, here's page 5. It says, using a straight edge, draw a large triangle ABC. So here's my ruler. Draw a large triangle ABC. Okay, so we can do that. All right, I'll make it black. Start at 0. And I don't know, let's make it length 15. Rotate it up, maybe a little further. How's that? And that's pretty good right there. And rotate it around, put 0 here, and bring this down like so. And then this is our third side here. And there is our large triangle. A, B, C. It says construct a circle inscribed in the given triangle. So guess what we're going to do? We are going to construct angle bisectors. So I'm going to put my compass at A, come out a little bit, draw an arc, bring my compass stylus over. I'm on there pretty good right there. Draw an arc inside, move it over to here. Okay. Right there. And there is my first bisector. So I'll do that one all in purple. This bisects angle A. Okay, there's my angle bisector. So basically what I'm saying is if this was X degrees, then this is X degrees, just like in the last diagram. Okay, I'm going to do that again now for B. So let me spin this around so it's not off the screen. Put my compass on B. Okay, try that again. There's my arrow. Okay, right about there. This one I'll do in blue, and I want to intersect both edges of that angle. Why does that keep doing that? All right. Okay, rotate this around. Draw an arc here. Bring this over to this intersection point. And draw an arc there. Where those two intersect will be where the angle bisector for B goes through. Okay. There's angle bisector B. Do the same thing now for C. Put my stylus right on. C right there, draw my arc, move this over to here. Draw an arc, move this up to here. And find where those two arcs intersect. There we go. And rotate, put this right 0 right there, rotate to C, and draw my bisector. Okay, so look at what just happened. All three met at this point in the center. It says construct a circle inscribed in the given triangle. So this is my center P. So I'm going to call my circle, circle P. So now I'm going to take my compass and now I need to draw a perpendicular to the point P. You want to go straight down. So I'm just going to do this quickly since this is time consuming. I'm just going to use my ruler at 90 degrees here. So there is a perpendicular. That is going to be the radius of my circle. Okay. Okay, so now this should come around. It's off just a little bit there. And there you go. Okay, pretty close though. If I just move this over just a smidge, or maybe make my radius just a little bit bigger. Okay, but that's pretty close right there. All right, so there's the circle. So I wonder if I could just drag this out just a hair to make it touch. A little bit more. And then move it right about there. Okay, so now that's tangent to all three sides. So there's a circle inscribed in a triangle. Explain why your construction worked. Okay, the point P from exercise 4 is the same distance from all three sides of triangle ABC. Thus, the perpendicular segments from point P to each side are the same length. A line is tangent to a circle if and only if the line is perpendicular to a radius where the radius meets the circle. Therefore, a circle with center P and radius the length of the perpendicular segment from P to the sides is inscribed in the triangle. C says, do you know another name for the intersection of the angle bisectors in this situation? Okay, we have done it already. Okay, and it is called the incenter of the triangle. Okay, page 6 brings us to the end of lesson 12. Review the lesson summary and go to your problem set.